Good. Okay. Now that you can see my screen, we can start right away from where we stopped the other time. So those who attended the lesson, can you remind us what we studied the other time? Who attended? You raise up your hand and you tell me. Uganda. Those who attended the lesson, can you raise up your hand? I'm not seeing anybody raising up the hand. Agaba, did you attend the lesson? Yes, yes, Melody, Melody. Yes, Melody.
We learned about density.
Very good. Melody, can you tell us briefly what we learned about density?
We learned how to measure density, to know density in liquids.
Okay, we said density equals to mass over volume, not so? We said density equals to mass over what? Mass over
yes.
Volume. Good. We said that when you want to measure the density by calculations, you need the mass.
Lesson here, senior one.
We need the mass, and you need also the volume of the substance. From there, we say that you divide mass by volume. Good. We never stopped there. We also went ahead to compare densities of some substances, where we said that if a substance or an object is more dense than water, then it is able to sink in water. If it is less dense than water, then it is most likely not to sink in water. So from there, we saw some liquid which can float on water. We saw some liquid which can sink in water. We said the liquid to sink in water, it must be denser than water. We saw how to determine density by calculation. We said if you are to determine density by calculation, we need the mass and the volume. Then we divide the two to get the density. Today, we are going to see how to determine density by calculation, by experiment. Hope you can see my screen very well.
Yes.
Yeah, for those who have just joined, this program is sponsored by Edify Uganda with support from ICC Teachers Association of Uganda. And I'm known by the name Teacher Alira Daniel. For the newcomers, those who were there last time, I introduced myself to you. So let's see right away how to determine the density, determining density experimentally. But we're going to start by determining the density of a liquid. So we want to see, how do you determine the density of a liquid? You can tell us steps. If I give you people, there's water here. I want its density, okay? You can tell us what you would do. I want some stop writing on my screen. You can tell us how you would determine the density of a liquid. I give you water, I say, I want the density of the liquid. Yes, Melody. Yes, Melody? Melody? Okay, I must see. Can you put your hands up and you tell me how would you determine the density of water? Who can give us? Yes, Asna. Nansubuga.
Teacher,
Yes.
determining the density of a liquid.
Yes.
I know the volume of a liquid is measured using a cylinder and it is measured as V.
Very good. You need to know the volume of the liquid. You first measure the liquid, its volume using a measuring cylinder. Next.
And empty it, empty and dry the measuring cylinder. Then is weighed in a beam balance and it is measured not M0. Also, the liquid is then added into the measuring cylinder and it is weighed again and its mass noted as M1. Then lastly, the mass of the liquid is then determined from M equals M1 minus M0.
Good.
The density of the liquid can be calculated from the formula density equals mass of the liquid out of volume of a liquid.
Come on, thank you so much. God bless you. That was wonderful. That was nice. Thank you, thank you. Can I hear from another person? Can I hear from another person? How would you determine the density of a liquid? So water. Can I hear from another person? Who can take us through determining the density of a liquid like water? Who can give us again? Yes, Percy? Yes, Percy.
By measuring using a measuring cylinder.
You measure using a measuring cylinder. Okay, great. Let's hear from Adenorod. Adenorod Precious.
The density of a liquid is mass of the liquid divided by its volume.
The density of the liquid is calculated by determining its mass and divided by its volume. Thank you so much, Precious. Wonderful. Good. Let me hear from another person. Mariam. Mariam, can I hear from you? Okay. Let me hear from Everest. Everest.
Using a Eureka can.
By using a
Eureka can.
By using Eureka can. Everest says by using Eureka can. Okay, good. Well tried. Can I hear from Joshua? If I give you water, I tell you, please, can you determine for me the density of this water? Yes, Joshua?
Yes.
Yes, can you determine for us the density of water? Yes, Joshua? Oh, we can't hear from Joshua. Let me pick the last person. Who could be the last person? Who is that lucky person? The last person? Next can through Emanuela. Emanuela, you're the luckiest person.
To find the density of the liquid,
Yeah.
first find
Yes.
its volume by
Very good. You first find its volume.
measuring cylinder. Then to find its mass. Then to find the mass, we get an empty beaker. Measure
Yes.
the mass of the beaker and an electric Then put the water in the beaker and measure
Yes.
so that to find the mass of the liquid with size of the beaker with the liquid in it minus the mass of the beaker alone.
Okay, very good. Then thereafter,
Then you divide the mass by the volume.
Very, very good. Good girl, Emanuela. Thank you so much. You such nice learners. I see Shadrach is saying displacement method. Somebody saying displacement method. That is Shadrach. Displacement method, yeah, it measures the volume only, not the density. Somebody is asking here, senior 2 lesson is at 2 p.m. Yeah, that is true. Nailina, you wait for it now. Let's see together. Density of a liquid. If I'm to measure the density of the liquid, I need to go to the laboratory and I get the following materials. Material number 1. Do you see the materials that I need? Material number 1, I need an empty beaker. That is 1. 2, I need the weighing scale. The weighing scale may be a beam balance, that is triple beam balance, electronic weighing machine, or a spring balance. Unfortunately, we can't do this physically, but we are supposed to do this in the lab. And if we don't have laboratories at home, I would send you to go and determine for me the densities for some liquids, which I would give you. So we need a weighing scale. We need an empty beaker. I also need the measuring what? Cylinder. Why a measuring cylinder? I need a measuring cylinder to measure the volume of water. I need the weighing scale to measure the mass of water. Now, these are the steps which we take. Even the liquid whose density is required, we also need it. So we need the liquid whose density is required. We take the following steps. Step number 1, we shall pour the liquid whose density is required into the measuring cylinder.
Excuse me.
Can you stop writing? So we pour the liquid whose density is required into the measuring cylinder.
Excuse me, sir.
Yes.
I would like you to go back to the previous page.
The previous slide?
Yeah.
Okay, let me go back to the previous slide.
Yeah, just for a second.
Yes, yes.
I just wanted to take a screenshot because I haven't yet finished. Yeah.
Okay, it's fine. But I'll send you the notes. We are going to send the notes on our Google Drive. The notes will be on our Google Drive, okay?
Yep.
So don't worry about the notes. We shall send it on our Google Drive. We shall send you the link also as well.
Yeah.
We say we pour the liquid whose density is required into the measuring cylinder. Okay. So I was posing a question here. Why do we put the liquid in the measuring cylinder? Please raise up your hand. I don't want the chorus answers. Why do we put the liquid in the measuring cylinder? Raise up your hand. Let me see. Yes, gift.
Teacher,
Yes. Why do we put the liquid in the measuring cylinder? Yes, Joseph.
Measure the volume of water.
Very good. To find the volume of the liquid. Very good. Very good. A sharp boy. I like that. Good. So after putting it there, that means we have to determine its volume. So we say we pour the liquid, which this is required, into the measuring cylinder. Thereafter, we read and record its volume. We are calling its volume to be VL. That is the volume of the liquid. Good. Then that is our liquid in the beaker, in the measuring cylinder. Do you see my liquid? Do you see the liquid in the cylinder? We call it to be VL. Is that okay?
Yes.
Yeah. After calling it to be VL, which is this, we now go to the next procedure. The next procedure is to weigh and record the mass of an empty beaker. So remember we had our beaker, so now we weigh its mass. After weighing the mass, we shall pour this liquid into the beaker. Again, we shall reweigh it. We shall reweigh the mass of the beaker and its content. So from there, we shall get the mass of the liquid from the mass of the beaker plus the content minus the mass of the empty beaker alone. So we shall share, we are saying we weigh and record the mass MB of an empty beaker. Then after doing that, we shall transfer this liquid, which already we know the volume. We transfer this liquid into the beaker. You can see my liquid in the beaker. This is the mass of an empty beaker. We are calling it to be MB. We are calling it to be MB. Then from there, we are saying you transfer the liquid into the beaker. After transferring the liquid into the beaker, we shall measure or weigh the mass of the beaker plus the liquid. So we shall weigh the mass of the beaker and that of the liquid, that is the mass of the beaker and its content, and we shall call it to be MC.
yes, sir.
Good. Now, how do we obtain the mass of water now, the mass of the liquid now? Raise up your hand. How do we obtain now the mass of the liquid now? Please raise up your hand. How do we obtain the mass of the liquid now? How? Raise up your hand. How to obtain the mass of the liquid now? Yes, Lucas. Yes, Lucas, I've picked you already. Okay, let me hear from Anderson. Anderson?
Teacher, for me, I think we obtain the mass by getting the total mass of the beaker and the quantity inside.
Yes.
Minus that one, minus the mass of the beaker.
Very good. You are too correct. Very accurate. So you get the mass of the liquid and the beaker minus the mass of the beaker alone. So there you get the mass of our liquid. So we obtain the mass of the liquid from the expression. Do you see this expression down? Do you see this expression down?
Yes, sir.
Yeah, mass of the liquid.
Yes.
Yes. Mass of the liquid equals to mass of the content minus the mass of the beaker alone. Is that okay?
Yes.
Yes.
Good. Then
Yes. I don't understand. Yes, is equal to mass over volume.
somebody says that I don't understand how to raise up the hand. Teacher, please. I don't. That's
complicated.
Somebody saying that we are going too fast. Okay. You know the speed. Gabi,
Master, I'm not understanding.
we are going to know the speed.
You're complicated, man.
I'm not understanding.
Master, can you please bring it on the page?
Master, me too, I'm not understanding.
You're going too fast.
Hello.
Stop disturbing us.
Hello.
Sure, we are not understanding.
You're saying.
I'm not understanding.
Go back to the second page.
Move on to what? Don't write on the screen.
Start from the beginning.
Excuse me, teacher.
Hello.
Excuse me, teacher.
Yes.
I did get it. But we're gonna
Can we mute ourselves?
Teacher, we don't understand.
We are not understanding.
Teacher, go.
Excuse me, teacher.
Hello.
Excuse me, teacher.
Excuse me.
Yes, please.
Go back to the next 2 pages or something.
Excuse me.
I don't understand.
Teacher.
Those who have just joined today. Hello. Those who have just joined today.
Yes.
Those are, I know those who have just joined today. No, sir.
Yes.
And we are the people who are not getting what I'm talking about. No, sir.
Yes.
I'm aware. I'm very sorry for that. Is that okay?
Yes.
But we are building on from the last lesson which we had. The last lesson was on Monday.
Okay.
And so the whole story started from there. We are just building on from where we stopped on Monday. Is that okay?
Yes. No.
Now what I'm going to do, I'll send for you the notes of last Monday.
Thank you.
Okay, thank
So
you.
that you can follow it very well.
Yes.
Wednesday we started last Monday. Is that okay?
Okay. Yes.
Yeah.
Yes.
So you pay attention to what we are talking about now.
Yeah.
And the most important thing is to know that density is given by mass divided by volume. Is that okay?
Yes.
Let's get there. Density is given by mass divided by volume. Is that okay?
Yes.
Yeah, I'm very sure those who attended the lesson last week, they don't have any big problem. But nevertheless, for us to teach whether a student, we teach those who are absent and present.
Okay.
Don't worry, I'm going to consider those who are not around the other Sunday. I mean the other Monday.
Okay.
Yeah. In case you don't feel free to ask the question, okay?
Yes.
Yeah, don't keep quiet. Don't say that, the teacher said that I was not around the other Sunday.
Okay.
Make sure you ask questions. Is that fine?
Okay.
Yes.
Thank you. So we were determining the mass, we were determining the density of a liquid. We said to get the density of the liquid, you need its mass and its volume. So you need the mass of the liquid and the volume of the liquid. And we said to get the volume of the liquid, you use the measuring cylinders. To get the mass of the liquid, you use measuring cylinders. Yeah, I see Eliza is telling other friends that those who have joined for the first time, just focus. It is hard to pick it for the first time. Don't worry, I'm here for you. Don't worry, those who have joined for the first time. Is that okay?
Yes.
Yes.
Good. So we are saying that to get the density of the liquid, you need the mass of the liquid and the volume of the liquid. After doing that, you divide mass by volume. And all along, I've been explaining how to get the density, the volume. We say to get the volume, you use a measuring cylinder. Use a measuring cylinder. Good. Then, to get the mass of the liquid, you first measure the mass of the beaker. After measuring the mass of the beaker, you pour the liquid. Then after you measure the mass of the beaker and the liquid, then to get the mass of the liquid now, you get the mass of the beaker plus the liquid minus the mass of the beaker alone. Is that okay?
Yeah.
Good. Now, from there, we said you divide now mass by the what? By the volume. To obtain the what? To obtain density. Very good. Very good. You're saying the density can be calculated from the liquid divided by the volume of the liquid. Now, is there any question?
Let us go back and
Mass equals to the total mass of the beaker and water minus mass of the beaker alone. Thank you. Eric, you're very correct. I'm reading the chat. Eric, you're very correct.
Excuse me, sir.
Yes.
On M equals MC minus MB, I'm not understanding that.
M equals to MC minus MB.
On the materials.
Here, right?
Used.
Yes.
Yeah. Now.
But a little back.
Here, we're saying ML. Do you see ML?
Yes.
Is the mass of the liquid. Is that okay?
Yes.
Yep.
It is the same as mass of MC, okay?
Yes.
Is the mass of the liquid plus the liquid. Mass of the beaker plus the liquid. Do you get me?
yes.
No.
Mass of the mass of the beaker plus the liquid.
Yes.
Then MB is the mass of the beaker alone. Is that clear?
Yes, sir.
Yes.
If I want mass of the liquid, it's the same as mass of the total mass of the liquid plus the beaker minus the mass of the liquid, mass of the beaker alone. Is that okay?
Yes.
Okay. Can we go to the calculations?
Yes.
Yes.
Okay. Good. Let's go and see calculation number 1. I want us to be careful on calculations, okay?
Yes.
Who can read for us that?
Teacher,
Who can read for us the question? Yes. Okay, read.
teacher, an empty beaker weighs 120.
and 180 grams when filled with methylated spirit.
If the volume of the spirit
is
is
75
75
centimeters
centimeters
cube.
Find
Find the density of the
Okay, now let us stop from there. Before we go to the solution, okay? Do you hear me very well?
Yes.
Good.
Yes.
Good. Let me highlight something here. They're saying that an empty what? Do you see this? An empty beaker weighs what?
120
grams.
Very good. That is an empty what?
An empty beaker.
But when it is, yes, when it is filled with methylated spirit, okay?
Yes.
It weighs how many?
180
180
grams.
Can I ask you a simple question?
Yes.
What is the mass of the spirit?
Pardon.
What will be the mass of the methylated spirit?
60 grams.
60 grams. Very good. Who is that person?
Tracy.
Tracy, thank you so much. It will be 60 grams. Tracy, how did you get your 60 grams?
I got the mass of the methylated spirit and the big.
Very good. Very, very good. So, members, let's look here. An empty beaker weighs 120 grams and 180 grams. When filled with methylated spirit. That means that the mass of the methylated spirit will be this one minus this. Somebody writing on my board, remove. Good. Now, of the spirit, who is this? If the volume of the spirit is 25 centimeters cube, is that okay? Find the density of the methylated spirit in grams per centimeters cube. Good. Let's look at solution number 1. What have we been given? Who can tell us what we have been given? Who has been given to us?
The mass of the empty beaker. We have been given the mass of the empty beaker.
Very good. You have been given
the mass of the empty beaker.
Yes, mass of an empty beaker. 20 grams.
Spirit.
So let us mute ourselves. If you are not talking, let's mute ourselves. Just mute, please. Just mute. Don't write on the board, please. Hello. Do you people hear me very well?
Yes.
Let us be good. Let us be good students. We should not write on the board. Is that okay?
Yes.
Yeah. Let us not write on the board. We are saying we have been given the mass of an empty beaker, which is 120 grams. Is that okay?
Yes.
We have been given the mass of the beaker and the spirit, which is 180 grams. Is that okay?
Yes.
So, to get the mass of the spirit, what is the mass of the spirit?
Another 180 minus 120 grams.
Which gives us
60 grams.
Very good. Now, we are also given the volume of the spirit, not so?
Yes.
Is that okay?
Yes.
So, you know the mass of the spirit, not so?
Yes.
The volume of the spirit, also?
Yes.
Can you get the density now?
Yes.
Who can get it for us?
Density equals mass of
Uh-huh. Yes, Armstrong. 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 Hello, Armstrong.
Teacher, I'm not understanding.
Armstrong.
Stop.
Who can get for us? How do you get now the density of the spirit?
Mass divided by volume.
Mass divided by volume. No, so from density equals to mass the volume. You can remind us what was our mass?
60 grams. 60 grams.
Grams. Very good. So our mass was 60 grams. Then our volume was what?
70 centimeters.
Very good. When you divide the two, how many people are having calculators?
Okay.
How many people are having calculators?
The answer is 1.25.
1.25. Who gave us the answer? Please get for us. Get for us. What is 75? I mean 60 divided by 75.
0.5. 0.8.
Very good, very good, very good, very good. Very good. You guys, do you know what?
No.
You are very active, very, very active. Who attended my first lesson?
.8 centimeters.
Very good. Who attended my first lesson? Can I attended the first lesson?
No.
Yes, Melody. You attended, right?
No. I did not.
Yes.
You attended.
Yes.
Good. Melody, I have a simple question for you. Are you ready?
Yes.
How many kilograms per meters cubed are there in 1 gram?
1,000 grams.
How many kilograms? I mean, how many kilograms per meters cubed are there in 1 gram? Meters cubed.
1,000 kilograms.
Very, very good. Very, very, very good.
1,000.
1,000.
It is 1,000. So, remember, part B is 8 grams per centimeters what in cube. Is that okay?
Yes.
Yes.
So part B says we want the density in kilograms per meters. Okay. So what we do, we just come and convert this one. Okay, do you see this?
Yes.
Yes.
We just convert it to kilograms per meters what? Per meters cubed. Is that okay?
Yes.
Yeah. Remember we said 1 gram per centimeters cube. Okay. We said 1 gram per centimeters cube equals to 1,000 kilograms per meters what? Cube. Who can tell us what about 0.8 grams per centimeters cube? What will it be equal to? Somebody should raise up their hand. If 1 gram is 1,000 grams per meters cubed, what about 0.8 grams per centimeters cubed? Yes, Faith. Yes, Faith.
I'm not sure.
Very, very good. Very, very good. Okay, what's the answer? Tracy, I'm going to call the dad.
To the power
My mom.
Excuse me, teacher.
Yes.
Teacher, I'm requesting to clarify for those who have not understood that.
Yeah. Good.
So,
in the previous lesson,
Teacher, what does the power?
in the previous lesson, we said that 1 gram per centimeter cube. Do you see my pen?
Yes.
1 gram per centimeter cube is equal to 1,000 kilograms per meters what? Cube. It is like this one is the unit, okay? Don't worry about this. This is the unit of density. Are you seeing this one?
Yes.
It's the unit of density. Is that okay?
Yes.
This one is also a unit. Are you seeing this one?
A unit.
Yeah. So we are saying that 1 is equal to 1 what is 1,000. Is that okay?
Yes.
Then what about 0. What is 0.8? Okay.
Yes.
We can say it is equals to what? Equals to, let's say, x. Is that okay?
Yes.
Then x we cross multiply. We multiply this by that, then this by this one, okay?
Yes.
So x times 1, what do you get? 1x, okay?
Yes.
Should be equals to 0.8 times 1,000, you get what? 800.
800.
Is that clear now? Good. So that's why gave us 8 what? 800. Kilogram, right? The other unit, kilograms per meters what? Per meters cube. Is that okay?
Yes, sir.
Is it okay to everyone?
Yes, sir.
Yes, sir.
Let's go to the next number.
Yeah.
Oh, good. The next number says 18. Okay.
Question.
Yes.
There is another method for that number. If we say 0.8 times 1,000 and we remove that 0 and a point and we put 0 divided by 10 times 1,000.
That is very correct. Very, very correct. Yeah. Who is this one talking? Who is this?
Excuse me, teacher.
Sorry, can I know your name? You're called Emma. Emmanuel, eh?
Yes, teacher.
Okay, Emmanuel, I'm looking forward to make you the class captain. Daniel,
Thank you, teacher.
I'm looking forward to make you a class captain. Is that fine? Kale, keep participating. We shall announce you as the class captain. Is that fine?
Okay, teacher, it's fine.
Let us see this question. Do we see the question?
Yes.
A tin containing 6 times 10 to the power negative 3. It is in exponential form, not so?
Yes.
It's in standard form, eh?
Yes, teacher.
If you want to write this one as 0.0, how do you write it?
0.6.
0.0.
If I don't want to write it like this, I want to write it 0. It will be 0. Oh, please give me the answer. 0.006, okay? Very good. So this is 0.006 meters what? Meters cubed. Is that okay?
Yes, sir.
Good. So we're saying that a tin containing 6 times 10 to the power negative 3 meters cubed of a paint has a mass of 8 kilograms. Do you see 8 kilograms?
Yes, sir.
8 kilograms?
Yes.
What is it? We have 8 kilograms now.
The mass of the paint.
Kilograms now.
The mass of the paint.
And the tin, okay?
Yes.
Remember, the tin contains the paint. Okay?
Yeah.
And the mass is 8 kilograms. Is that okay?
Yes, sir.
That means that the mass of the tin and the paint is 8 kilograms. Is that okay?
Yes.
Yes.
If the mass of an empty tin is 0.5 kilograms, do you hear that?
Yes. Yes.
Yes.
What is the mass of the paint? What would be the mass of the paint?
The mass of the
8 kilograms minus 0.5 kilograms.
Very good. Very, very good. Very, very good. So, if the mass of the empty tin is 0.5 kilograms, calculate the density of the paint in kilograms per meters cubed. Is that okay?
Yes.
Yes.
So, we go to given. See what is given? We are given the volume of the paint. Do you see the volume of the paint?
Yes.
Yep.
Yes.
It is 6 times 10 to power. Remember we said this one is equivalent to
0.006.
very good, very good, very good. Then we also given the mass of the tin plus the paint. Is that clear?
Yes, sir.
We also have the mass of an empty tin. Is that okay?
Yes.
That means that the mass of the paint is going to be 8 minus,
Minus
0.5.
which gives us what?
7.5.
10.5
Very good, very good. Kilograms.
grams.
Don't forget the volume of the paint was already given to us, okay?
Excuse me, teacher.
Yes.
Yes, your excuse, please.
I thought that mass is measured in meters, then volume is measured in kilograms.
Oh, very good question. But now mass is measured in kilograms. Is that okay? Please speak it from me that mass is measured in kilograms and volume is measured in meters cubed. Is that okay?
Yes. Yes.
Yes, teacher.
Okay. Can we move on now?
Yes.
Yes.
Remember, we already had the volume, and this is the mass, okay? So what will be the density now?
Mass over volume.
Mass over volume, very good. So our density will be mass over volume. What is our mass in this case?
7.5.
What was our volume?
0.006.
0.006. When you divide this, what do you get?
1,250.
Very good. That is so great. Okay. That is in kilograms per meters what? Very good, very good. Now, what we're going to do, we are again going to convert it to gram, to gram per centimeters cube. Is that okay?
Yes.
Yes.
1 gram per centimeters cube equals to how many kilograms per meters cube?
1,000 kilograms per meter cube.
Very good. So, solution to part B, from 1,000 kilograms per meters cube equals to 1 gram per centimeters cube. Is that okay?
Yes.
That means that 1,250 grams per meter cube equals to that. When you do this, what do you get?
1.25.
Very, very good. Very, very
good.
Very, very good. So, is there any question? Is everything clear?
Yes.
Are you sure?
Yes.
Yes, sir.
Yes. Sure everything is okay?
Yes,
okay.
teacher, it is okay.
If I give you
Excuse me.
if I give you a number to do for me,
Excuse me.
Yes, teacher.
Yes.
We are ready.
please. Okay. Yes,
Teacher,
yes, please, your excuse.
I have not understood the second example.
How to convert from kilograms per meter cube to grams per centimeter cube, eh?
No, no, the first part.
The first part.
Excuse me, teacher.
The first part.
Martha.
So we are saying the container, a tube contains 6 times 10 to the power negative 3 meters cube of paint and has a mass of 8 kilograms. So that one, do you see here? This one becomes the volume of the paint. Is that okay?
Yes.
Volume of the paint. That's why we have recorded it here as the volume of the what? Of the paint. You see that? And this one becomes the mass of the paint plus the tin. Is that clear?
Yes.
Mass of the paint plus the what? Plus the tin. Is that okay?
Yes.
Then an empty tin has a mass of 0.5. So this is the mass of the empty what? Tin.
Empty.
So if I want the mass of the paint, it will be 0.8. 8 minus 0.5. Is that okay?
Yes.
Which gives us 7 point what? 7.5. Then we say density equals to mass divided by what?
Volume.
volume. So mass is already 7.5. Volume was already 0.006. Is that okay?
Yes.
Good. Then we divide that. When we divide, we get this one as the answer. Is that clear?
Yes.
Very good. Can I go to the next thing?
Yes.
Okay. Yes.
We don't convert that 10 to power negatively to 1 out of 1,000.
You can convert it. Only that you are using a calculator. Is that okay? Yeah, I'm assuming that we are using a calculator. We press it and we get it. Is that okay?
Yes.
Okay. Now, do you see that heading?
Yes.
It is written what?
Activity 1.
You have leaking here?
Excuse me, teacher.
Yes.
How can you get the work?
We are going to post one on the Google Drive. We shall send you the link. Is that okay?
Yes.
Then two, we shall add you on our WhatsApp group. You can also get it from there. Is that okay?
Yes, teacher.
Yes, teacher.
Those who are taking the screenshot, can you take the screenshot for this?
Excuse me, sir.
Yes.
Can you get for us a WhatsApp link?
Get somewhere and you write for my WhatsApp number. I'll write for the link. I will add you there. You write my number. Are you ready to write?
Yes.
070.
Yes.
Teacher, pardon.
070.
Yes.
375. 0.
Yeah.
387.
Is this the WhatsApp number?
Yes,
Teacher,
yes.
can you repeat it? WhatsApp number.
070.
Yes.
375.
Yes.
Teacher Daniel. Teacher Daniel.
Yes.
Teacher Daniel.
Yes.
Yes. Okay, guys. Senior one, can you listen attentively? Senior one, mute your microphone. Mute your microphone.
Teacher, pardon.
Mute your microphone first.
Teacher.
Mute your microphone and listen.
Yes,
Mute your microphone. All right, thank you so much. Guys, you can check the link. I've shared the link. One is for...
I'll try to beg your pardon.
Listen.
Teacher,
listen.
we wanted to know your number. We didn't hear you.
Okay.
It's on the
chat. Yeah, check the WhatsApp. Check the chat section. I've shared two links. One is for joining the Google Classroom, and one is for WhatsApp group. Click on the link and you join Google Classroom where the work will be posted. But today also we are going to send the work on WhatsApp. Okay, Teacher Daniel, can you clarify it to them?
Yeah, it's okay. Now, class, do you hear me well?
Yes.
Now, I'm quiet I talk. We are saying we are going to share the link to you for Google Classroom. Is that okay?
It's already there. It's
already on the chat. Then for the added on WhatsApp group, I told you, you inbox me, I will add you. Is that okay?
Yes.
Yeah, I've given you my numbers. Have you seen the number?
No.
Those are not. Okay.
We have seen your number.
Okay. So this is activity number 1. Have you seen activity number 1?
Yes.
There is.
Good. Can you write very fast?
So we have
finished.
Then activity number 2, I'll just post it, okay?
Yep. Yes.
I'm going to post it on WhatsApp. Just inbox me, I'll send you the work, okay?
Okay.
Then, thank you so much for being good students.
It's okay, teacher. It's okay.
You're welcome.
Thank you.